Algebra 1 students, I'm going to walk you through these notes to your future forgetful selves. This one is on radicals and roots. This is from the activity that we did when we found the area of the tilted squares. Hopefully you've already engaged with that activity. The link for it was in the assignment in Schoology. And you saw that we can write a radical as the side length of a square of area A. Okay? So radicals are roots. They are a type of number that when you multiply them a certain number of times, you get the radicand, the number that's underneath the radical sign. So these particular numbers can be rational. Those are the perfect squares. The square root of 4 is 2. You multiply 2 times itself once, and you get 4. The square root of 9 is 3. 16 is 4, and so forth. Okay? These are rational numbers. You can write them as a ratio of 2 integers, as a fraction. They also have irrational roots. Okay? These are radicals that are not perfect squares. You cannot represent these numbers as the ratio of integers or a fraction. They are never-ending, non-repeating decimals. However, these numbers are real. Okay, they are part of the real number system. They appear on the number line, and they have properties like other numbers. Okay, so on this page, we go into how to simplify these expressions, this type of expression. So there are several properties that govern the behavior of roots. We only learn one of them in Algebra 1. We learn one so that we can simplify quadratic solutions. The property that we learn is called the multiplication property of square roots. And it goes like this. If I have a number underneath a radical sign that has more than one factor, so in other words, there are two numbers that multiply to make the big number that's underneath the radical sign, I can split that into two separate factors, the square root of one factor and the square root of another factor. Okay? Likewise, the multiplication property of square roots says that if I have two radicals, I can multiply them together and put the entire new number underneath one radical sign. However, this section up here, outlined by the light blue box, this is the part we use to simplify radicals. Okay? So why do we want to simplify these numbers? Well, just like fractions, like 6/8, if you get a fraction as a solution to a problem and it's in a form like 6/8, you have to reduce it, right? Your teachers always taught you that. You want it down to its simplest form. Well, radicals need to be simplified in the same way, okay? Only to simplify a radical, you pull out any perfect square factors, like 4, 9, 16, 25, etc. And you continue to find these perfect square factors until you don't have any more left. So let's have a simple example, okay? Sometimes you'll look at a number and you'll know off the top of your head if there is a perfect square factor of this number. Like 8 is super easy to see. I've got the square root of 4 times the square root of 2, and the square root of 4 is a perfect square. So it's going to simplify to the positive number 2, because 2 times 2 is 4. Okay? So look what I've got. Look at this radical. This radical is now in simplest form. There are no perfect square factors of the number 2. So I can stop and rewrite the square root of 8 as 2 root 2. Okay, that's what that means. When you're dealing with a number that's larger, I just want to say that you have to get a calculator and you have to guess. If it were me, I would make a list of the first several perfect square factors, perfect squares, okay? 36 is 6 squared. 25, 5 squared. 16, 4 squared. 9, 3 squared. And 4, 2 squared. At our level of mathematics, more than likely, you are not going to have to come up with a perfect square factor that is larger than that. Okay? So you literally just guess. You take your large radicand and you just start dividing it. And you're looking for a perfect square that divides your number that has an even integer as the other factor. Then you know that you can pull that perfect square out of there and deal with the other number that's left. So I hope this is helpful. Please contact me if you have any more questions, and I'll see you in the next video.